So we're now going to walk through the overview of the MathServices app case study. And this particular case study is going to show how various Java concurrency frameworks can be applied using Spring Web MVC to interact with a pair of math services. One that's going to do the greatest common divisor or GCD functionality, the other which is going to be checking for prime number primality. We've seen that before, so we're going to take a look at it again in a different context. Unlike the previous examples we've looked at, you can see that these are going to have two separate microservices rather than trying to glom everything into a single microservice. As usual, you can get this at my live lessons GitHub repository in the EX3 project in the Web MVC folder. So this case study is going to show how Spring Web MVC can be used to send and receive HTTP GET requests synchronously to and from parallel clients and multiple microservices. So we're going to see there's parallel computing on the client side using Java structured concurrency, and then we're going to see two different models on the server side, one of which is going to use parallel streams and one of which is going to use a different variant of structured concurrency. So lots of concurrency and lots of different models here in this case study. The client is going to send all these requests to the microservices in parallel using the structured task scope shutdown on failure structured concurrency model. We've talked about that before. You'll get a chance to see that here when we start walking through the code in more detail. The two microservices are going to receive these requests in bulk. That is, we're going to send a big chunk of integers over for different kinds of processing, either the greatest common divisor or GCD processing or the prime checking processing. And they're going to be processed in parallel again using either Java structured concurrency via the thread per task executor model or the parallel streams model. So once again, lots of different variations here to see, compare and contrast in a Rosetta Stone-like way how these things work. So let's talk about how the MathServices app project is structured. We organize it into several modules and packages like usual. On the server side, we've got a microservices folder that contains the app entry points, the GCD application and primality application, which are pretty much boilerplate. We're going to have a couple of controllers for the GCD and primality microservices. They're also very standard. And then the service implementation strategies are where we do things a little bit more interesting by showcasing the thread per task executor and the Java parallel streams model. And in this case, we're actually going to use the virtual thread per task executor implementation. There's a common package, which is going to consolidate various project-specific helper classes. We're going to have things here that are Java records for sending and receiving different kinds of typed parameters like the GCD results and the prime results. We're also going to have something cool called the list splitterator, which we're going to use to convert the incoming list of integers for the GCD application into things that are going to be used to process in parallel with pairs of greatest common divisor integers. We'll look at that when we get into the code. And as usual, we have a constants file and an options file. There's also a set of other reusable helper classes that can be applied in many contexts, not just in this example application. So here we have mathutils, which implements the GCD algorithm and the primality checker. And we've also got future utils, which we've been using with our Java 19 and Java 20 structured task scope APIs, which take futures and deal with futures. And then finally, there's a resources folder that has things like the microservices names and the port numbers and so on and so forth. On the client side, we've got the MathServices driver. This is the main test driver that will send and receive requests and responses to and from the microservices using Java structured concurrency. So we're going to have fun looking at that. That's an interesting approach. Very simple, but also a very common way now of trying to do embarrassingly parallel or invoke all style operations in web services environments implemented with Java. There's also a client folder where we've got the proxies for talking to the GCD application and the primality application. And this also contains this wrapper class called MathServices client that encapsulates everything and gives the test driver a nice simple method call interface that it can invoke. There's also a couple more utils classes that handle things like generating random numbers, also handles things related to web programming so we can bundle up a bunch of stuff and make GET requests in ways that you've also seen before. Nothing really different here. And then finally, we have another resources folder that keeps track of various application properties, including demonstrating how to enable and disable logging, which turns out to be very helpful because we're writing our MathServices driver as a command line application in Spring. And if we don't disable the logging when it starts up, it just spews tons of debugging information to us that probably isn't useful in most situations. So we can disable it in this configuration file. So now that we've talked about the MathServices app, let's talk a bit about how things work in terms of the pros and cons. As with everything, there's pros and cons. So one of the nice things about this application, unlike what we looked at before, is that each microservice runs in its own process and therefore could be mapped to different computers in a cluster, in a data center, or in a cloud environment. So it allows us to be able to scale up the system. And if we went to a little bit more effort, we could also improve reliability and scalability by using things like replicas and standby sparing and load balancing and so on and so forth. We haven't gone to that level of effort here, but we're setting the stage to do that. Of course, not everything is rainbows and unicorns, as I like to say. So some of the downsides here is that we have to explicitly program the client to communicate and connect with each microservice explicitly. And this just kind of complicates things because the configuration and deployment and launching of the microservices, as we'll see when we run the program later, just takes more effort manually. Testing is a little bit more complicated. However, this is mostly due to what I'm teaching in the course at this point. In later parts of the course, we will simplify a lot of this by using things like discovery services and API gateways. And if you take other courses at Vanderbilt, for example, the course on cloud computing and programming cloud environments, you'll learn about how to do deployment and configuration with environments like Docker and Kubernetes. So be aware that we're teaching things incrementally. And so some of the stuff that's a limitation here can easily be worked around once you know more sophisticated ways of using Spring and popular web service infrastructure. So that's the end of our discussion of the MathServices app case study. And now we'll get into the details in the upcoming videos.